Okay, now I'm into the final video from the check understandings for chapter 10-7. This is going to be about choosing an appropriate method. We've learned a variety of methods for solving quadratics. One is factoring, another is completing the square, and then the reference is graphing. If you have a graphing calculator handy, if you graph your quadratic function and you find your x-intercepts, well, that tells you the solutions for it when the function is equal to 0. And tells you lots of other information like the vertex and the y-intercept, which could tell you something about what you're dealing with. Or square roots. So if it's just like x squared equals 81 or x squared minus 81 equals 0, you can rearrange that and just get the square root of both sides, and that's the square root solution. It's something we've done, we just haven't labeled it very much. But look at some problems. So they give some examples. 2x squared minus 6 equals 0. Suggest the square root of the approach. And that can be done very easily. You take 2x squared minus 6, you add 6 to both sides. Yep, 2x squared equals 6. And then you would divide both sides by 2, and you have x squared equals 3. And you get the square root of both sides. You get x equals plus or minus the square root of 3. This next one has pretty ugly coefficients. You got 6x squared plus 13x minus 17. This is not going to be a factorable one. Maybe it's factorable, but I don't think so. And it's also really not going to lend itself to completing the square, because completing the square, you'll have to divide everything by 6, and then you'll have a middle term that's 13 over 6. And then you'll be adding the square of 13 twelfths. And who wants to do that? So let's just plug and play. Plug A, which is 6, B, which is 13, and C, which is negative 17 into the quadratic formula. C, it's actually pretty easy to factor, because negative 3 times positive 5 is 15. So you'd have x minus 3 times x plus 5, and then your solutions are negative 5 and positive 3. D, definitely using quadratic formula. I agree. All of my coefficients are annoying and big. And this one, it looks like you could factor it, but there really aren't any factors of 4 that neatly will make negative 7. So quadratic formula or completing the square or graphing, any of those would work. So it's definitely not going to be factoring. So let's look at our options down at the bottom. We got 13x squared minus 5x plus 21 equals 0. In this case, I would use quadratic formula because my lead coefficient is 13. I've got all sorts of ugly coefficients. Negative 5 isn't so bad, but it does make completing the square annoying. If I wanted to complete the square, I'd divide everything by 13. I have x squared minus 5/13 x plus 21 over 13 equals 0. And then I would have to add something to both sides that was the square of 5 over not 13, negative 5 over 13, but negative 5 over 26. And I really don't want to do that. So I'm going to say A is 13, B is negative 5, and C is 21. And then I'm going to use the quadratic formula for that. So let's go ahead and do that. So A is 13. So A is now 13. B is 5. And C is 5 or negative 5? Negative 5. And that's negative 5. And C is 21. Okay. Give this business here. Problem. And now we have our solutions. Our solutions are ugly. We could round them to the nearest hundredth. Negative 1.48 and 1.09 would be our solutions for that one. Quadratic formula definitely on that one. This next one we could factor, because there are two factors of negative 30 that -1, -6, and +5. So x minus 6 times x minus 5 equals 0. So x minus 6 times x plus 5. So you'd have x could be 6 and x could be -5. I'll demonstrate that over here. I'll just go ahead and put that in here. So x minus 6, x plus 5 equals 0. Okay. And actually, once I set it up that way, it's not giving me solutions. So actually, maybe it is. Let's check. Yes, it is actually. So we have solutions at -5, +6. Solutions, I mean x-intercepts, and I mean the roots, and I mean the zeros. The zero meaning when the function equals 0. So if I were to graph this as equals y, you can see it has those two x-intercepts. You can also see it has a y-intercept of -30, and you can also notice that it has a x at 1x is 1/2. So our original equation is x squared minus -x. A is 1, b is -1. So our vertex is going to be at -b over 2a. So that's 1. Negative of -1 is 1 over 2 times 1. So that's 1/2, and that is in fact the x value. Then you plug in 0.5 to the whole equation, and you get -30.25. So the last here, 144 squared equals 25. In this case, I'm going to just use a square root approach. I'm going to divide both sides by 144 first, and I'll just go ahead into Desmos, and I'll do this. So I've got 144x squared equals 25. I can rearrange that into x squared equals 25 over 144. And you get the square root of both sides. So x will equal plus or minus square root of 25 144, so it's 5/12. Or x equals -5/12. And those are my solutions. And I'm done. Okay, so the big idea for this one here is to think a lot about which method you're using. A lot of times when we get to the quadratic formula, a number of students want to always use the quadratic formula for every single problem. And it will work for every single problem, but frankly, I really use it if I can factor it easily, or I can use the root method, or even if the completion of the square method is really simple to use. So use it when it's the easiest thing. It's a little cumbersome, as you noticed in class, but use it if it's the easiest thing. Use other things if they're the easy things. So follow the of mathematics is designed to make things easy. Let it work out that way. All right, I hope this is helpful. And now that you've watched this, I'm going to be asking you to try some exercises. I know you're very excited about that.